Okay, Geometry Chapter 8, Section 4. This is the last section of the chapter. We're going to look at proportionality theorems. So we're going to take a look at this triangle here. We have one relationship there where EB is going to be parallel to DC. Okay, so we'll put the little parallel triangles on it. Not congruent, but parallel. What that's going to do is that's going to allow us to set up proportions of the sides of these triangles. So if those two things are parallel, then it is true that, that AE over ED is proportional to AB over BC. Again, that only holds true if EB is parallel to DC. Now, the converse of that one, I'm not going to worry about putting the converse up here, is if they give you the proportion AE over ED equals AB over BC, then that means that EB is parallel to DC. So it's kind of just working a little bit backwards with it. And so let's look at an example where we can get something here. Now let's take that triangle there. Let's throw a parallel right there. Let's go ahead and label that. Again, the labels will be just a little bit different. Let's go A, B, C, D, E. And we're going to call AB 4, BC is 6, DC is 9, and then ED we don't know. And they would tell you that AE is parallel to BD. And maybe we want to find the length of EC. To do that, we need to find out what ED is. So that's going to be our X. And because those two things are parallel, that means I can set up a proportion that 4 to 6 is the same as X to 9. And so that's going to give me 6X equals 36. Divide both sides by 6. In this case, X equals 6. So that's not our answer. That means ED is 6. And so when I add that together, 6 plus 9, that's going to give me 15. So in this case, EC would be equal to 15. Okay, and the next one has to do with parallel lines. So let's say we have 3 parallel lines. I mean, you're just walking down the road and you just randomly see 3 parallel lines. And in this case, those parallel lines are cut by transversals. We're going to label this R. Whoa, don't want to do that. We're going to label this R, S, T. And this will be line L, and this will be line M. Okay, so R, S, T, L, and M. And then we're going to go with angles of U, W, Y. Actually, let's do this. Let's go U, V, W, X, Y, Z. Those are the actual, not the angles, those are the intersection points. So that's my mistake. And so if we have 3 parallel lines that are cut by 2 transversals, then they cut those transversals proportionally. So UW over WY is going to be equal to what? I'll bet you can probably put this one together. UW over WY is going to be equal to VX over XZ. And so we can look at different segments in the work tomorrow. But as long as you've got 3 parallel lines cut by 2 transversals, we are going to have proportional sections. And the final one is triangle bisector theorem. So let's take a look at just a standard right triangle. It doesn't have to be a right triangle, but we're just going to use that one. And I'm going to call that ABC. And so we're going to have a bisector that's going to cut angle, cut angle C. And so since that's 90 degrees, we know it's going to be about, I like the lining up. There we go. So about half. That's pretty close. We're going to call that intersection point D. So the bisector means, let's go with a little bit of color. The bisector means that those 2 angles right there are congruent. Okay, and so if the ray bisects the angle, which that's CD in that case, and it divides the opposite side into segments whose length are proportional. So in this case, AD over DB, get back to the black here, AD over DB is going to be proportional to CA over CB. So anytime you have a bisector of an angle, the side that it cuts in half, or excuse me, the side that it cuts through after it cuts the angle in half, those 2 pieces are going to be proportional to the actual other 2 legs of the triangle. And so that's right at about 7.5 minutes. That is Chapter 8, Section 4, Proportionality Theorems.